Okay, so the door just closed, so I'm going to start talking. I was just informed by the fantastic news that this room is actually rented out at 5:30. So my session is 50 minutes, which is 5:35. So we're going to go over, and the people are going to come in here and try to sit down. Just fend them off at the door, and we'll finish this session. I'll try not to go over as I normally do. So I'm going to be talking a little bit about patterns, and you're probably not going to learn a whole lot of new stuff, to be perfectly honest. But you're going to be able, hopefully, to put names to certain things, and there might be some new stuff as well. So my name is Klug. I work for 1337 here in Stockholm as right now a meeting participant. I think that's my title, because that's all I do. But I am a software developer, architect, and public speaker at conferences around the world for different things. But I'm kind of uninteresting, so let's just carry on. So I was going to talk about software patterns, because I wanted to talk about something that I enjoy talking about, and I enjoy doing at conferences. And I was like, I need a new session. Software patterns are kind of cool, and it's a good thing to talk about. So I'm going to do that. So we're going to start out with talking about what are software patterns. Software patterns, if you go to Wikipedia, I'm going to have a lot of Wikipedia stuff up here because I know for a fact that everything on Wikipedia is true. So a software design pattern is a general reusable solution to a commonly occurring problem within a given context in software design. Makes sense, right? You know the problem with this statement? We're going to look at it as like, okay, general reusable solution. To a software developer, that is like saying, this works for everything, we can use it all over the place, and it will solve all our problems. Right? It says it's general, and it says it's reusable, thus can be implemented all over the place. They missed the little thing with within a given context. Software patterns is not a solution looking for a problem. Basically, I have a solution, then I need to find somewhere to put it in. Basically, you come up, I have a problem, you go back and you look at, has someone else had this problem before me? Yes, they have. They have defined how to solve it in a useful way, and they are potentially smarter than you guys, so don't reinvent the wheel. I just assume that people that write stuff like this is smarter than me, and that would probably be most of you as well. So just let them do their work, and you can do a little bit less of the hard stuff. So it is not, and I want to cover this, it's not a solution to everything. I'm not saying that you're going to go home, I'm going to show you a few patterns, but you can go home and you can read the Gang of 4 books about pattern in enterprise architecture and stuff like that. And you're going to try to put that into every solution that you have, and that is not the goal. But it's kind of cool to know some of the patterns because they're easier to discuss when you know the names of them, because you can sit there and say, oh, we should apply an adapter here, or we should apply a decorator here, or whatever. It's not so much the pattern in itself, it's kind of knowing a little bit about what they mean as well as the names so that we can reason about them. So I came up, okay, I'm going to cover, let's go ahead and look at a bunch of patterns, right? That's the goal of the session today. So I thought I'm going to cover a whole bunch of things. I'm going to figure out all these really cool patterns. I'm going to cover all the ones that everyone knows, and I'm going to find new patterns, and I'm going to cover, and then they said, you've got an hour. And at this conference, they said, you've got 50 minutes. Which means that I cannot cover all of them. But I did learn one interesting thing researching this conference, for this session or this talk. If you Google software design patterns, you get the same patterns for all over the place. There are only 24, I think it is, design patterns in the world, apparently, if you Google it. And they were written in 1994 in a book by the Gang of 4, and those are apparently the only ones that exist, because if you Google software design pattern and you go to Wikipedia or wherever, they will document the 24 patterns for you and nothing else. If you then happen to know the name of a few other patterns, you can Google them, but you need to know the name of the patterns before you can figure out what they actually do. So what I did, instead of going, we're going to cover a ton of things, I said, I want to take up some stuff that is confusing. I want to pull out some cool patterns that I like. I want to have one that is ridiculously misunderstood, and I'm going to have a few useful ones as well. So that's kind of the goal. I got a few patterns, and we'll have a look at those. And disclaimer. If you go online and you start Google this and you start doing what Chris said was not that, nope, because my patterns are a little bit different than the ones that you will find on the interwebs. Because on the interwebs, you will see the original Gang of 4 patterns, which are all based on code that was written before 1994, which means that they didn't use interfaces and things like that. So they're all based on base classes and inheritance and all of that. With modern stuff like C#, we can use interfaces instead of inheritance and a few things. So my samples are slightly more modern versions of the originals when there are original inheritance and stuff in the system. So, confusing stuff. Just do some nerd exercises. You know what that means. That means put up your arm. If you get tired, put up your other arm. Just keep your arms up. How many of you have heard about the adapter pattern? That's pretty much all of you. How many can explain it? Yep, there's one hand. There's a stage here. Okay. Decorator pattern? Explain it? Damn it. Okay. Facade? Explain it? There's one hand, go, okay. Or two. Proxy? And bridge? It's getting less and less. Either you're getting tired, which is really weak. I know we're developers, but that is really weak. Or you're getting less and less. Adapter is common. So I'm going to look at this, and the reason I pull these up together is because they kind of are similar, but still not really similar. They do look the same, but they are actually different things. So I'm going to start out with the adapter pattern. And if you go to Wikipedia, you get this. The adapter pattern is a software design pattern that allows the interface of an existing class to be used as another interface. Ta-da! Makes sense. It adapts something. So if we look at that, so if you have a problem, basically, you have an interface that you need to use, but you have an implementation that doesn't implement that interface. What you do is you create an adapter in between that makes sure that the interface that you have can be used from the interface that you want. Makes pretty much sense. So if we look at this, we've got an app here. It calls log on the iLogger interface. The iLogger interface is an interface. The implementation is log4net adapter, which then implements iLogger. But iLogger has a log function, and log4net doesn't have a log function. It has an info function, for example, or an info warn, whatever. So to be able to use log4net in my client app, I need to create that little log4net adapter to be able to get log4net to do what I want with the interface that I have. So it doesn't change the functionality. It kind of depends on the idea that log4net does what you need. The API is just wrong for it. It's not, I have something that does something else that needs. It's all about, I have a feature or a function or a class that does what I need, but it needs a different API. That's about it. That's all you do. So you wrap inside of your, there will be code. Inside of your log4net adapter, you will have an instance of the log4net logger, and basically just adapt the call. So most of your adapters will just be logger.log calls log4net thingy.info instead. So it's just a very thin little thing that just maps things back and forth. Make sense? So most of you had heard about adapter. How many of you have implemented this at some point? How many of you knew that it was an adapter? Now you can explain it to, because you knew what it was. I said you're not going to learn anything here. I'm just going to give you names. Decorator. And the decorator is kind of similar, but not. The decorator pattern allows behavior to be added to an individual object dynamically. When you read the definition, it sounds very different, but when you look at the implementation, it actually looks kind of similar. But the problem that you have is you have an implementation that does most of what you need, but it doesn't do all of it. So say that you have logging. I like logging. All of my demos are logging based. Say you have a logger and it basically logs to disk continuously. And then you say, actually, I don't want to log to disk continuously because it's slow and I want to add batching to it. Instead of inheriting that logger and adding stuff to it or creating a new version of it or whatever, what we do is we create a batching logger that basically wraps the original logger and adds the batching functionality. So it looks like this. Client app believes it's talking to an iLogger, but it's actually talking to a batch decorator, which implements iLogger, which in turn internally has another iLogger, which happens to be the log4net logger, which also implements the iLogger. So it means that we take a class, we have it implement the interface that we want, it takes an instance of the thing that we're using, like iLogger in this case, and wraps that and adds stuff on top of it. So in this case, the batch decorator can add batching by basically not calling the log method on to the next implementer until it's reached a certain size of the batch, and then it basically batches all of them at once. The cool thing with the decorator is that since the decorator in the constructor, in most cases, takes an implementation of the same interface, we can just wrap them. So I can go ahead and add, in this case, an env-info decorator, which also implements iLogger. And that could then go ahead and say, oh, so in my logging, I actually want to get it to log all of the environment information currently as well on top of it, but that's not implemented in the logger. But instead of having to go around to every place where I do the logging and add the environment information in every single log statement, I add a decorator around the implementation I have, and I add the logging changes in there. So you can basically extend the functionality and add more features to some form of implementation by having a decorator that basically just wraps it and adds more features. Make sense? Weirdly enough, I don't see this often enough. You see inheritance instead. You see this and you go, oh, I need to add more functionality, I need to have batching, so I'll actually go and inherit the logger and add batching in the inherited class. The downside to that is that we can't mix and match. We can't do, oh, let's take the logger and let's add some batching and some of this and some of that. Instead, you need to inherit all of these different versions of it and make a decision instead of just adding functionality based on decorators instead. Facade. This is funny because that's where most of your hands went down. Actually, no, sorry. Bridge was, but facade, there were a few hands as well. Facade is really, really simple. Promise you have done it. A facade is an object that serves as a front-facing interface masking more complex underlying or structural code. Once again, Wikipedia. Source of truth. So the project that you have is that you're talking to a system that is complex and complicated. And to be able to integrate with this system, you might need a bunch of extra knowledge. It might be something that you don't need to read up on, it's just slightly complicated, or it might actually be a really complicated system that needs you to know, or requires you to know a bunch of information to be able to use it. What you do is you then go and say, I'll create a facade in front of that with a much simpler API, and then I'll hide all of that complicated ugliness behind a much simpler implementation. So for example, I left the logger, I just want to mention that. I have a car in this case. So how many of you have a driver's license? Okay, cool. In Stockholm, you never know. So starting a car is it's not a complicated process, but it does involve a few things. You need to press the clutch, right? And you need to turn the key. And you need to insert the key first. So there are 3 things to be able to start a car. Or can we agree? Having to teach somebody who doesn't know how to start a car that they need to insert the key, press the clutch, and turn the key is much more complicated than having to just tell them, push this button. So what we do is, we have a car, then we create a facade in front of the car that basically has a much simpler API. The car facade has a start method. So the client only needs to call start, then the facade hides the fact that it needs to do 3 different things to actually get that end result, and we can just abstract away complications. I'm not saying that starting a car is complicated, but you could have way more with things having to log in and keep state and things like that the facade can do for you, making it a lot easier to work with. And then as I said, there will be code samples. I will show you this as well. I just want to walk through them so you know what they are. The proxy definition is a wrapper or agent object that is being called by the client to access the real serving object. Most of us know the proxy from remote calls. It doesn't necessarily need to be remote calls. It's just a matter of creating some form of class. Actually, I think the problem statement is here, sorry. The component you want to talk to is not part of your system, but needs to work as if it is. It can be some other things as well, but that's the general description. So you need an object that when you work with it, you think you're working with something that's there. It's something you have in your system and you just call things on it. But in the real world, it might actually in most cases be a remote call. So when you call do X on your local instance, what is actually happening is that that instance does a bunch of magical network thingamajigs and talks to something else, gets it sorted out, gets response back, does all the serialization, all the communication, all of the complex stuff. But to you as a developer with your proxy, you call the proxy and you're done. But as I said, the definition is not that it necessarily has to be a remote object in any way. It can actually, as I'm going to have in my code, be something completely different. It could be that you have a very heavy, complex object that is hard to create or whatever that you can proxy in front of and add different proxies to and things like that. But the normal way we see it is remote proxying to web services or .NET remoting or anything like that. I assume 90% of the people in the room, or probably 100, have done web service calls at some point. We all do. And it used to be that you could right-click and say add service reference and you got a proxy. Now it's all that REST stuff and it's complicated and hard to build. So this is kind of what we're looking at normally in most cases. We have the client app just knowing the switch. The switch implementation is a switch proxy, and the switch proxy basically calls off to a switch somewhere else to do its work. So it's just a way of doing something on something else, but it looks like you're doing it locally. And as I said, not necessarily process or network boundary crossing, but generally that is what we're seeing. And the final one, which is kind of, they're all ish similar, is bridge. The bridge pattern is funky, because I started looking at that, and then I went, ooh, is that a bridge? I have done bridges many times in my life. I had no clue. The bridge pattern is meant to, this is funky, decouple an abstraction from its implementation so that the two can vary independently. So does this make sense to anyone? Because reading it like that, it doesn't make a whole lot of sense to me. So the problem you have is you have an abstraction, you're abstracting away something that basically is built on two different dimensions. So there are two things that can change in your abstraction. Okay. Imagine this. You are building an eye-shape renderer that needs to render shapes. And rendering shapes, I want to be able to do that in two ways. I want to render it either in default mode or as high contrast, because people with poor visibility need high contrast rendering instead. But I also want to make sure that I can render it not only on WinForm, for some reason, but in WPF as well. So with those two axes, with default and high contrast and WinForm and WPF, those are basically two different requirements that affects my eye-shape render abstraction. I end up with 4 implementations, right? So we would normally, in a lot of cases, just go and implement 4 of these. So we would have the default WinForm, default WPF, high contrast WinForm, high contrast WPF. That is all fine until somebody goes and says, by the way, grayscale would be really cool as well. Okay, so we add grayscale, so that's 2 more. So now we've got 6 different versions of it. And then somebody comes and says, dude, that Xamarin thing is really cool. Now we've got 9 implementations of it. And you can see how this basically blows out of proportion. All of a sudden you got a ton of different implementations. But they're all actually kind of doing the same thing, right? Parts of it is the same, because a bit of logic in each one of the WinForm, WPF, and Xamarin is going to be replicated across these 9 implementations. And they're also going to have, all of the ones that have the default implementation are going to have common logic as well, right? So we're actually getting common knowledge, but it's getting spread out across different things. So with the bridge, what we do is we split those two apart. So instead of having one implementation taking care of both axes, we have one implementation for each axis. So we have an implementation eye-shape render called default and high contrast. That one in turn takes another abstraction, which is the eye renderer, which has the information about WinForms and WPF. That means that whenever we add high contrast and Xamarin, we add one level up at the eye-shape renderer level, which just adds high contrast, so we can get that logic in there. And then at the bottom, we add another renderer, and then we can combine them however we want. So the high contrast one takes an eye renderer in its constructor and then can do its thing, and we don't need to end up doing 9 things. We only need 6. there's still lots of stuff to be implemented, of course, but it kind of depends on how many different versions you have. I had no idea that this was called a bridge. I've learned that now, so I'm going to go around sprinkling bridge all over my stuff in the future. Having that said, I do end up doing way more. We do more than this. This is very common today, to be perfectly honest. We are doing this a lot with composition over inheritance. So instead of inheriting and doing a bunch of different classes, we do this. We basically compose our stuff together in a different way. So bridge is the idea, oh, there are two axes we need to take care of. And I'm looking at it and I'm going, I have solutions where we got 57 different things affecting it, and we just basically compose things to whatever we need. But the bridge is basically a two-axis version. So if you look at it, just as a little graph here, or a grid, the adapter and the decorator are very similar because they wrap their implementation. They take another implementation as input, and then they wrap that, while the adapter changes the interface of the wrapped type into whatever they need, whereas the decorator keeps the interface and adds features to it. Facade doesn't wrap anything, it's a completely new thing, but it creates a new interface, but the functionality that it's exposing to the end user is actually the same. It's just doing it in a different way and making it easier to use. Proxy doesn't wrap anything, it uses an existing interface. The only difference is that it's using an interface that's probably located over there somehow, so the interface of your class is going to be the same, but there's going to be magic and unicorns in between. And the bridge is kind of, it wraps parts of its logic, and then has its own implementation for some, and so on. But they are kind of similar, but they do partly different things as well. So I'm going to show you a little bit of code. And this code is available on GitHub. I'll give you the address later on. This was scary. This thing flexes when I lean on it. As you can see, you might not see, but there are a lot of folders out here. I have created a bunch of implementations for a lot of different patterns because, as I said, I was supposed to cover a ton of patterns in my talk. There are more here than I will talk about, so if you want to dig in and have a look at the code, there are other things than the stuff that I talk about. So if we look at the adapter quickly, what we see here is we've got an iLogger interface. We have a log4net logger implementation of iLogger. And it basically creates an internal version of the log4net logger, and the log thing here adapts. So it gives us one API out, which is a log that takes a level and a message, and it adapts that to log info, log debug, log warning, and log error in the implementation that we have. Pretty basic stuff. Next one was let's say that was adapter. Let's look at the decorator. So here, I've got two different examples. I've got a logger, and I have my fantastic Is It Friday service. We all need one of those. So we have an Is It Friday service here, and it exposes a Is It Friday method, which looks like that. If you don't know how to implement that feature in C#, it looks like that. And this is kind of cool, but I obviously don't want to load up my application with figuring out the day of the week continuously over and over and over again and use all my resources for that. So to be able to cache that response, no, this is not a reasonable way of doing it, but you get the point. I can have a caching decorator. It also implements Is It Friday service. It takes an Is It Friday service as input as well as a cache timeout. It exposes the Is It Friday service just in the same way that it should because of the interface, and then it has caching logic here to figure out whether or not there's a cached value of whether or not it's a Friday. And then obviously we want to be able to log this as well. So I have a logging decorator that takes an Is It Friday service, and when you call it, it adds logging to the system. And then I can compose these nicely up here in my fantastic application to say, create my service. And you see here the reference is SVC is Is It Friday service. Then I reassign that variable to the caching decorator that wraps this thing, and then I reassign it to the logging decorator that wraps the caching decorator. So I've got these onion layers of things. So internally, in the innermost, we've got the actual implementation, but I now can ask this ever many times I want because it is now caching my result and it's logging it so I can figure out any exceptions coming out of it. We have the facade. This seems a little bit stupid. I didn't want to do a remote call, so I went with the definition that sorry, for facade. Ignore me. It was the proxy. I was one step ahead. So the facade here, we got a logging facade, iLogger. It takes a log level. It takes a message. So we recognize the iLogger that we had before. But the implementation I have is a console logger. So the console logger actually takes a type and a color and a format and a log level and a message, and figures out to write really pretty log messages to your console. This is a bit too hard for my developers that I work with to figure out. So to make it simpler, I have created this little facade here that only has a log. But then based on the level and the message, I can go ahead and I can figure out the format that should be used and what color should be used and things like that. But end user only needs to go and say log, level, message, done, and then it goes ahead and does the adapt or the facading of the more complicated implementation. These examples seem kind of dumb when you're only talking about logging, I know, but in a bigger, more complex environment, they actually make a lot of sense. Next one would be the proxy. This is the one that I said that actually the next one was, actually it was, yes. This one goes with the idea that a proxy doesn't need to be external. It doesn't need to be a remote call. In this case, I am actually using just a proxy to create a singleton. So my proxy here is basically just an instance of Is It Friday service, and it goes ahead and creates an instance here. So this acts as a proxy in the way that when I call Is It Friday service, it goes and calls my instance here, and it basically becomes a proxy to a singleton. Is that the way that we normally do it? No. But if I want to show you the remoting stuff, I would have to do remoting, and I didn't feel like having a web application in here, and I did not want to show you .NET remoting. Has anyone ever used .NET remoting? Yeah, there's a guy down here laughing. Okay. And the final one is bridge. So what I did here is I took my logger and I broke it down into an iLogger and an iLog writer, because that's kind of the two things we can split apart. So the iLogger has a log method and the writer has a write method. So the logger is responsible for formatting and the log writer for writing it. And then I have my simple logger, which implements iLogger, takes a log writer in and uses the log writer to write the entry. We've got the advanced logger, takes a log writer. So all of these just take a writer in, but they have different formatting depending on which one I choose. And the writer here either writes out to console or to log4net. And then I can, in my application here, combine them however I want. But in the end, I get an iLogger, which is basically can do a ton of different things depending on how I compose my classes. Does that make sense? And all of you have already done this at some point in your life. We all have, kind of. The next one is visitor pattern. Visitor pattern is awesome. And I have never used it, ever. Not a single time. Has anyone tried using the visitor pattern? Knows what it is? There's one guy, two guys, three guys, four guys. Okay, there are a couple of you in here. It's kind of not me, at least, because this should kind of, yeah, okay. Anyhow, visitor pattern. So the visitor pattern is interesting. It's a way of separating an algorithm from an object structure on which it operates. Okay, what does that mean? Well, the problem you have is you have an object, or many objects, but you need to add algorithms to do calculations or different things based on those objects in a good way, and you can do it afterwards. It's kind of like a decorator in the way that you can add features to them, but it's kind of a way of adding features without wrapping the object. So what we do is we do this. You have a client, you have two items in this case, and you have a visitor. The visitor is the abstraction for the algorithm that you're trying to add to the items. And okay, I'm just gonna keep going. So the visitor is the abstraction we have of the algorithm, and the items are the things that we want to basically use for our algorithms. So the client creates a visitor of some sort, some form of algorithm as an object, and passes that into item A by calling accept on item A. Apparently accept is the standard term for sending a visitor to an item. The item then takes inside of the accept call, it calls visit element on the visitor thing, passing itself in. So I am passing in a thing that gets the other thing passed into itself. Okay, why is this useful? I will show you. But what happens after that is that the visitor then goes back to the item and starts looking at the item and does whatever algorithmic thingy-majigs it needs to do, and out at the other end it gives you a result. And then the client can go ahead and it can call accept visitor on item B, which can be a completely different type. And then that type calls visit element and passes itself into the visitor. The visitor goes back and looks at that object and does calculations. This is actually kind of cool because it doesn't break open-close principle. It actually allows us to make these changes to the classes without breaking the open-close principles of Solid, which is hard to do in other ways if you want to add functionality to something that doesn't have it to begin with. One thing to note though is, since the object is passing itself into the visitor and the visitor looks at it, the visitor can only operate on public things. So it can never access anything internally, it's only public API. So if we look at what that looks like, I will show you kind of why this is cool. And I'm going to do this really quickly. I suggest that you have a look at this because it's a kind of a I'm not allowed to say that word, mind-bending experience, let's use that, to figure out how this works. But so I have this main method here, and I have a square, a circle, and a text. So imagine that you're writing some software that's going to render stuff on the screen. And square, circle, and text, they are all different types. They do not have they do have a common interface, which is I am visitable. It doesn't need to have, but I happen to put that in here now. But they don't expose any form of functionality of calculating area or anything like that. They're just width, height, and a top left in the case of square. Circle has a radius and a center, and the text has some font size and text and a few little other parameters. They have nothing in there. But I come up with this that, I actually want to be able to calculate the area required for one of these things. So I create, in the case of calculate area, I have an area calculator visitor. If I can open that. So there's an area calculator visitor. I take whatever object I have, which is visitable, and call accept on it, passing in the visitor. If we then look at, for example, the square, in the accept method, it says visitor visit this and passes itself into the visitor. And in the area calculation visitor, if we look at visit, it has one for each one of the types that it supports. And if we look at the square one, the algorithm for calculating the area is within that thing. So we can go ahead and get that out. So after having passed in the area calculator or calculating visitor to the square, also it does not show it. Sorry, let's go down here. We can then go and look at the visitor, and it has an area property that exposes what it's come up with. But I can then go ahead, okay, area is one thing. How about total area? In that case, I take an I enumerable and I visitable, I pass in the visitor sums up all the areas over time as it gets it's allowed to visit different objects, and I get the total area of everything I've passed in. Or calculate drawing area. This thing here, somebody had to show me how to do the math for this because I suck at math, so my dad is a math teacher. He had to show me a bunch of things in here, and basic things like how do you calculate an area for a circle? And I was like, I have no idea. I haven't been to school for ages. Whoever needs to do that. So this thing here, there's some logic in here to figure out drawing area calculator. It basically, based on the thing, it figures out the rectangle required to render that thing. And if you pass in multiple of them, it can go ahead and basically calculate the entire area you need to be able to render each one of these things. So even though square, circle, and text have no idea of being able to calculate area and things like that, I can add the functionality with those algorithms by using the visitor pattern. But Chris, you can do this in a ton of different ways that does not include the visitor pattern. Absolutely, and they're not half as complicated, but this is really cool if you look at it from a coding point of view. The other ones will also potentially break open close principle if you really care about that. Another one I have which I really like is the circuit breaker pattern. So circuit breaker pattern has become really popular with microservices where we put stuff into the cloud. And when we put stuff into the cloud, you know what the basic principle of stuff you put into the cloud is? It is potentially not going to be there when you need it. And I'm not kidding. That's a tenet of basically doing stuff in the cloud, that it will go up and down. So you always need multiple versions of the same thing and load balance those because stuff will go up and down. With the circuit breaker pattern, we kind of look at the idea that things can be offline for a period of time for different reasons. So I went to Wikipedia again, and I got the circuit breaker pattern is used to detect failures and encapsulates the logic of preventing a failure from constantly recurring. So what it does, the first problem it solves is that you have transient faults. For a short period of time, your service might be down. Say that you're in Azure, and your service is dependent on SQL Azure. SQL Azure is built on the premise that if you overload that with calls, it will actually tell you to not do that and stop responding. That's a transient thing, right? 1 second later, you can do the same call again, and it's going to be online, right? But if it's for a slightly longer time, my call to different services might be dependent on this. So basically, things can time out. There can be timeouts to calling other web services and things like that. So we don't want to make sure that if a service is down somewhere else, and you're basically calling it and it sits there and just waits to respond, you don't want your entire system to have a cascading failure because everyone is expecting someone to answer down there and you sit with timeouts all the time. So you want to get rid of those timeouts because it's going to basically kill your system. And the second one is that service in the other end that's experiencing the problem is slowly going to get loaded up with potentially thousands of requests that are just coming in, and it can't actually do anything because it's waiting for something else to clear out. So slowly you're killing that service, so it can't actually self-heal because while it's trying to heal and figure out its own little life problem, it's getting bombarded with questions from someone else trying to figure out their life problem, and you're basically killing that service from healing. So what the circuit breaker pattern does is I have a very simple demo of it here. Circuit breaker up here. So the circuit breaker is the idea that we wrap our... let's see if we can find what I want to show you. This is the one that I want. So I have an HTTP circuit breaker here, and if we look at the circuit breaker, what it does, it basically, I made a generic version of it just because I felt like it, but what it does is that when you call make request on it, you give it, so if we look up here, sorry, if we look, circuit breaker is there, there it is, request helper, make request, it gets a client and a circuit breaker. And what the circuit breaker does is inside the circuit breaker there's a a method called make request. And whenever you do a make request, it does the request inside of a try catch. If it fails, if that request fails, it records that failure in a failure count. And then if we look at when I do the failure count change or update, it basically says depending on the state, if you start adding failures up to a certain point, if I've failed 10 times in a row, I'm going to go ahead and basically kill it. I'm not going to allow any more requests going out. I'm going to throw an exception as soon as you try to make the request. And we can have a custom exception so I can figure out that it's being short-circuited by the circuit breaker. But the idea is that the circuit breaker keeps track of previous errors, and once you reach a certain level, it basically goes, no, that service is not working. I'm not going to sit here and wait for 20 seconds for your timeouts to occur. I'm actually going to kill it right now, fast speeding up your system, while at the same time letting that other service potentially heal and come back because something has been wrong with it. And then after time, this thing, I think this has a little extra thing in here, very basic version of it, which is, after a little while, the circuit breaker might actually go and say, I'm going to let one call through. So I'm going to break off every single call, except I'm going to let one call through. And if that call succeeds, then I'm actually going to open the circuit breaker again and let requests go through. So I basically once one or more calls succeed, I can go ahead and go, now you're allowed to call the service again. Mine is very, very basic, but if you're doing, I assume that most of you are doing .NET, right? How many, oh, there's one dude going, no, I know. Has anyone heard of a framework called Poly? How many of you are using Poly actively? The guy that did not do .NET is the guy that goes, I know Poly. Poly does exactly this. So Poly can add circuit breaking for you to your HTTP calls, and you can have really complex things with backup strategies and basically say, I need this many failing calls before it fails, and then if it fails, have a backup strategy and retry policies and a bunch of things like that. But circuit breaker is one part of Poly that makes it possible for you to, if you're doing web requests, you don't wait for your web request to time out, which might be 20 seconds. You get proper, this has failed 50 times before, I'm not even going to go there, here's just an error, it sucks. That last part was mine. That is not from the documentation of Poly. I got 10 more minutes. 5 if you ask the people who've rented room. I don't care. I got 10. Repository pattern. How many of you are using repository pattern? How many of you are using the repository pattern wrong? I love that most people go, I'm just going to accept that. I'm going to fail on this in any way. It's like, the repository pattern is probably one of the more used patterns in the way that most people know the name of it and they implement it, but it's also one of the ones that most people misuse, I think. Because if we go and look at the repository pattern, the definition, it is not on Wikipedia. I had to do my own definition, which is a repository abstracts away the data layer and centralizes the retrieval of domain objects. That's what the repository does. It gets domain objects for you. It gets them. Keep that in mind. So the problem is, you're building a domain or have domain objects, or you need to retrieve objects that are basically fully initialized objects, and you want to do that in a persistent, ignorant way. So you don't want to go and write your own C# or ADO.NET code or whatever towards the database and have your queries spread out across the entire system. You want to have predefined methods, get user by ID, get user in this location, get blah, 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 these different predefined methods. Before I go into the demo, I want to mention a couple of things here. First of all, did you mention how I said get objects? A repository does not persist objects. It is not the repository's responsibility to persist anything. It is only there to retrieve things. Anybody who adds a save method to a repository is A, not building a proper repository, and B, in for a world of hurt. Especially if you try to do it on top of Entity Framework. Because Entity Framework, if you add Entity Framework to ASP.NET Core and do it per request, you're going to get one context, right? Then you have multiple repositories pointing to that one context because you get the DB context injected into your repo, right? That is brilliant. And then when you call save on your repository goes and calls save on your DB context, right? Which doesn't actually save stuff from your repo, it saves any changed object from that DB context. Which actually means saving not stuff that you have done in your repo, saving stuff that you have done in every repo in that request. Do not do that. What are we going to do? I will show you what you're going to do, but I'm going to start out with some code. So the repository pattern is not complicated. As such, it's actually pretty simple. So I do have a database in here, but that doesn't really matter. What I want to show you here is I have a IUse repository and I have an implementation. The IUse repository has predefined methods for selecting users. And then I have the implementation here, but it does not have a save method. It does have a delete method. It does have an add method, but it does not have a save method. And I also want to highlight my naming strategy here, or I wanted to highlight two things. First of all, exposing iQueryable out of your repository is a really, really crap idea. Because what happens when you expose iQueryable out of your repo, that means that, I know some people like it, I just dislike it because we're spreading out logic of how to find different types of users throughout our entire system. Because all that query logic of how to find users based on X, Y, and Z is now in multiple places potentially, or probably. Say, for example, we build this simple, and then and you've got a few hundred website pages finding users and everything, and then somebody comes and says, oh, we need to support soft delete, so we need to make sure that every single query against our database includes is deleted equals false. And you have exposed iQueryable? Yes, you can go in and add iQueryable and then basically go and do your own stuff there, but in some case, you might end up, in some cases, having to go around and update all of your query logic throughout your application spread out, collect all of that into your repo with predefined methods. And also naming them like this is awesome, because your user repo is probably going to end up in a variable called users. So your code is going to be users who are admins, users that have been deleted, users whose first name starts with. It's very readable compared to users.get users by blah, 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 blah. So I kind of like that. I might have learned that from somebody else. And finally, how do we solve the problem of repositories not having a save? You do unit of work. So unit of work, definition is, according to Martin Fowler, maintains a list of objects affected by a business transaction and coordinates the writing out of changes and the resolution of concurrency problems. So the problem you have is that you have a bunch of modified entities that needs to be persisted in an atomic unit. Basically, there needs to be a transaction around it. You know what does that really, really well? Entity framework. Because entity framework's DB context is a unit of work. When you retrieve something from entity framework, it stores a reference to that object. When you modify it, it knows that it's been modified, and when you call save on your DB context, it will make sure that it keeps a list of modified entities, basically here, a list of objects that have been affected by basically modified. And when you call save, it saves all of them. So your DB context becomes your unit of work when it comes to entity framework. Which is why we do not go and add save to our repositories. We make sure that we do a unit of work around everything so that we can save it in a transactional unit that we know what it's doing. Doing it on one repository with entity framework is not great. So the implementation I have is also, once again, very simple. The whole thing in alphabetical order is complicated. So I have in this case I just do an in-memory store. I don't do entity framework as such. But what we do is basically we have a unit of work, which I have made into an object in this case. And the unit of work, if we go and look at that, it takes an I support unit of work item. And it has a complete method. And my memory store, my in-memory store, it has basically an in-memory database kind of thing where it keeps track of added and removed users, as well as once you edit them, basically they get into this as well. And it has, in this case, I did make it support unit of work like this complete explicitly, so it's not visible. So if you go in-memory store .complete, it's not going to be there. And this thing in turn goes ahead and basically saves all of the changes in one unit. This is not a great version of it. It's just that, once again, I had to do a bunch of entity framework work around it to show you. But I want you to keep in mind that unit of work and entity framework work really, really well together. And the DB context becomes your unit of work, which is why there's a save method on DB context, but not in your repo. The last thing I want to cover is, was anybody in Philip's talk in here yesterday or before me? He talked about all these null thingies that's coming out in C# 8 potentially. Null object solves some of those. So quickly, I've got 2 minutes. Null object. A null object is an object with no referenced value or with defined neutral null behavior. Okay. So the problem we have is that we end up doing null checks all of our code, right? How many of you have written this? You are lying. We have all written this. Wouldn't it be kind of awesome if we could write that and just remove if log not equals null? Or how many of us have done this? Get admins from the database. Look at that, yes. If admins is not equal to null, then we do it, because we can't do a for each in a null object. So the null object solution here is that, in this case, have an implementation of ilog or whatever it is, which is called null logger. the null logger doesn't do anything. It has no implementation. It has empty methods. So when you call them, nothing happens. And then whenever you use an ilog, pass in a null logger if you don't have one, and you don't have to do the null checks, because if you call log.write on a null logger, the null logger just goes, I don't care. Yeah, sure. But you don't need to have the null checks. For this, don't go and return null, return empty array. Or empty enumerable or whatever, so that you can make sure that you can remove that. Because if users.admins returns an empty array instead of null, I can go straight for reaching over them instead. Makes everything a lot easier. There's a hand going down there. I'm not going to do a demo right now, so I just want to thank you all for listening. And if you want to look at the code that I have, there's a lot of code in there and a bunch of things. There's a link here that you can have a look at. And if you want to have a chat with me or have any questions, I will not be around tonight. But I will be around. I'll be around for a few more minutes, and I'll be around from sort of 10-ish tomorrow, I think. I got another talk tomorrow. Thank you all for listening.